Hello everyone. The lecture number 3 for algorithms course lectures for second level students in Bورسعيد University, Faculty of Science, Department of Mathematics and Computer Science. The lecture title Analysis of Algorithms. Analysis of algorithms, the theoretical study of computer program performance and resource usage. What's more important than performance? Modularity, correctness, accountability, function, robustness, user friendliness, programmer time, simplicity. Reliability. Analysis of algorithm. Why study algorithm and performance? Algorithms help us to understand scalability, performance, often through the line between what is feasible and what is impossible. Algorithmic mathematics provides a language for talking about program behavior. The lessons of program performance generalize to other computing resources. Speed is fun. Running time. The running time depends on the input and already sorted sequence is easier to sort. Parameterize the running time by the size of the input, since short sequences are easier to sort than long ones. Generally, we seek upper bounds of the running time because everybody likes a guarantee. Kinds of analysis. The first type, or worst case, usually T of n equals the maximum time of algorithm on any input of size n. The second type, average case, sometimes T of n expected time of algorithm over all inputs of size n. Need assumption of statistical distribution of inputs. The third kind, or the third type, best case sheet with a slow algorithm that works fast on some input. Machine independent time, DRAM model. Machine independent algorithm design depends on hypothesis computer called random access machine, the abbreviation RAM. Assumptions: each simple operation such as addition, subtraction, takes and so takes exactly one time step. Loops and subroutines are not considered simple operations. Each memory access takes exactly one time step. Machine independent time. What is the inversion source? Worst case time. It depends on the speed of our computer, relative speed on the same machine, absolute speed on different machines. Big idea. I ignore machine depend constants. Look at growth of Tn as n is nearer to infinity. A symbiotic analysis. Machine independent time and examples. ABCD code for insertion sort. Insertion sort of A for G nearer to 2 to length the class A, and the second step 2 do K the class A of G. نبدأ insert the class A into the sorted sequence class A from 1 to J minus 1. I equals or is nearer to G minus 1 while I is greater than 0 and the class A of I greater than K. Sixth step, do the class A of I plus 1 implies to A the class A of I. Step number 7, I minus 1 implies to I. Step number 8, the class A of I plus 1 K to A of I plus 1. Analysis of insertion sort. Insertion sort A cost times the first for G from G to length of the class A, C1 cost C1 times N. The second step do from the cast C2 times N minus 1. The step 3 نبلغ insert of the A class A of G into the sorted sequence A from the class A from 1 to G minus 1. The cost equal 0 and times N minus 1. Step 4 from J minus 1 to I. What is the cost? The cost equals C4 and times N minus 1. While step number 5, while I is greater than 0 and A of I class greater than K, and the cost C5 and summation from J equals 2 of the power 2T J to N, the summation. The step number 6, do A of the class I plus 1 into from the class A of I to implies to A from the class A of I implies to A of I plus 1, and the cast equals C6, and summation from J equals to T of J minus 1 to N. The summation. Step number 7, this is the analysis of insertion sort. Step number 7, I from I minus 1 to I. For I minus 1 to I. The cost C7 and times summation from J equals 2 to N T of J minus 1. 8, the step 8, A of I plus 1 to K to A of I plus 1. The cost equal C8 and times N minus 1. The total running time is T of N equals C plus C2 times N minus 1 plus C4 times N minus 1 plus C5 times summation T of J from J equals 2 to N plus C6, the summation from J equals 2 to N Tj minus 1 plus C7, the total plus C7 summation Tj minus 1 and C8 times N minus 1. This is the total running time by the following equation. The best case, the array is already sorted. Tj equals 1 for j equals 2, 3, so on, so 2n. T of n equals c1 n is the best case. The equation of the best case, c1n, c2n minus 1, c4n minus 1, c5 plus c5n minus 1 plus c8 n minus 1. The common factor c1 plus c2 plus the common n c1, c2 plus c2 plus c4 plus c5 plus c8 times n minus c2 plus c4 plus c5 plus c8. The worst case, the array is reverse sorted. Tj equals j4, g equals 2, 3, so and so 2n. The summation j from j equals 1 to n equals n times n plus 1 over 2. This is the array T of n, the equation T of n equals C1n plus C2n minus 1 plus C5n times n plus 1 over 2 minus 1 plus C6n times 2n minus 1 over 2 plus C7n n times n minus 1 over 2 plus C8 times n minus 1. Then T of n equals A of n squared plus bn plus c. This the second degree equation or quadratic equation. Growth of functions. Although we can sometimes determine the exact running time of an algorithm, the extra precision is not usually worth the effort of computing it. For large inputs, the multiplicative constant and lower order terms of an exact running time are dominated by the effects of the input size itself.